Okay, now we're continuing on with the notes. We're talking about how to actually find exponential formulas, and I'm going to give you a consistent manner. And the first one is if there's a y-intercept given. And this is the easiest because, again, there's two steps, and let's go through each one. So first of all, if they give us 2 points, I want you to stack and rack. So I have the point 0, 72.3, and the other point I have is 3, 24.9344. Get over everything looking nice. Okay, so I have 2 points. And the beauty of this, I now have the y-intercept. This is nice. So I know the beginning, or my initial value. So I know the formula is y equals a b to the x. And what I'm looking for is the a and the b, the initial value, and for the b is the growth factor. The x, y are a bunch of points. So the first thing you're going to do is substitute in the y-intercept. So in the a spot, I'm going to put the 72.3 because that's my y-intercept, or my initial value. So I'm going to put it right there. So we're halfway. I just don't know the growth factor. So after you use the y-intercept, you're done with it. Now I have this other point hanging out. And isn't this point an x and a y? And if I'm trying to solve for b, if I plug the 3 in the x value and in the y put the 24.9344, I can solve it and find the b. So I put 24.9344 equals 72.3 b to the third. Now, I want you to be very careful. Do not round at all to the very end. It's very important. So I want to solve this for b. So let's divide each side by 72.3. So I have 24.9344 divided by 72.3, and that equals b cubed. Now, I don't really care about b cubed. I want b to the first power. I want to understand what b is. So what we're going to do is raise this to the reciprocal, because that will turn it to b to the first, because 3 times 1/3 is 1. And if I do that side, I have to do this side. So now, when I do that, and you put it just like this in your calculator, do not round it, don't do anything to it. When I do that, I get b to come out to be 0.701273. Now what I want you to do for your b, and this should say b right here, is to at least go 4 decimal places. At least 4. If you don't, it's going to change things and make things not correct. So this, I'm going to write it as 0.7013. Okay? So now I know what a is and b is. So my formula is y equals, and we already knew the a was 72.3. And the b is 0.7013 to the x. Now, let's box it. When I get done, and I want to make sure I'm right, if I put that in my graphing calculator, I should see these 2 points, or at least something close to it, because we've rounded. But the other thing I want you to notice is, notice how when my x's were going up, my y's were going down. So this is a decaying function. See how my b is between 0 and 1? So that makes me kind of happy that it's decaying, because it looks like it's going smaller. So I just found that formula. So the key points, you substitute your y value in first. Then you got to find your b, so you plug in your other point, x, y, solve it, and you have to raise it up to get b to the first power, and then make sure you round it to at least to 4 decimal places, and bam, you have your formula. Okay. Now the other way is not as easy, of course not, and this is if they don't give you the y-intercept, then you have to do a little bit more work. We still got to find a and b, but we have these 2 points, so let's stack and rack. I have 2, 180.5. The other point is 5, 19.345. Okay, now notice I don't have an initial value. So I have y equals ab to the x, because they said it's exponential. Well, remember, finding exponential functions is with ratios, so we're going to do a ratio of these 2 points. Now, notice how this x value is a little bit bigger. So I'm going to put this bottom point in first, and I'll show you why. It doesn't really matter, but it makes life easier. Aren't these x's here and these y's here? So in the y spot, so I'm going to actually take this formula and put those 2 points in it. So I have 19.345 is my y, equals a, which I don't know b, but I know my x is to the 5th. All right, so see how I just put that point in there? Then you have to do this divide thing, because it says divide the 2 equations in step 1? This is because it's a ratio. You have a ratio. So I have to put the other point in. So this is an x and a y. So I have 180.5 equals a b to the second. Now, when they're like this, a cool thing happens. Thanks for playing. The a's cancel right out. And since I have the same base, b to the 5th minus 2, b to the second is going to be b to the 3rd. So I have b to the 3rd equals this decimal. So please, again, do not round, do not change it. It doesn't need to be. You can put it in your calculator just the way it is. Now, I don't really care about b to the 3rd. I want to know what b is. So we're going to raise each side up to the reciprocal, or 1/3. And when I do that, I come out saying b is 0.475004, which we're going to round to 4 decimal places because that's good enough. I will tell you if it's not in this case. So I found b. And I check it and say, oh, wait a minute, this is between 0 and 1. Is this decaying? Well, you bet it is. Look at it. It went from 180.5 down to 19. So that's a pretty big, because that shows 47.5% is left. Okay? So now I have so far the formula y equals a 0.4750 to the x. Now, I have to find the a. So it doesn't matter which point you use now, is pick one. So I'm going to pick the top one, all right? And I'm going to put that in. So this is an x and y. So in the y spot, I put the 180.5 equals a 0.4750 raised to the 2. And when I do this, look at here. This is hooked by multiplication. So can I divide both things by this? So when I take a, it's 180.5 divided by 0.4750 squared. And when I do that, I get 800. So now I know my formula is y equals 800.4750 to the x. And that should make sense because it should be higher because it's decaying down. So now you've seen one of each way. Let's practice this again. Now this is the same table that you had before, but we didn't actually find the formula. We just looked to see which one was linear and one was exponential. So let's recall that this one was linear because it had a constant rate of change. And this one was exponential because it had a constant ratio of 1.2. So let's go through this and find the actual formula. So let's do the linear one. And I always like to stack and rack a couple points. So the 2 points we're going to use for everything, I'm going to put it up here, is 20, 30. Okay, for the linear. And then I'm going to use 20, we'll say 20, 30, 25, 45, sorry. Okay. So now the linear. So I have y equals b plus mx. And the slope is going to be delta y over delta x. So I'm doing 45 minus 30 all over 25 minus 20. So my slope comes out to be 15 over 5, or 3. So I have y equals b plus 3x. Plug in one of the points. So I'm going to use the point 20, 30. So I have 30 equals b plus 3 times 20. So b is going to equal negative 30. So my formula is, for the linear, y equals negative 30 plus 3x. Now let's do the exponential. Now the points we have for the exponential, we have our 21,000. And the next one is 1200. Okay. Again, this is exponential. I do not have the initial value. So I'm going to use y equals a b to the x. And we have to do the divide thing because I don't know the initial value. So I'm going to use this first because it's bigger. So I have 1200. That's the y equals a b to the 25th. Divide. Then I have 1000 equals a b to the 20th. So thanks for playing. So this comes out to be 1.2, or you can leave it the way it is b to the 5th. Now on this one right here, what we're going to do is I have b to the 5th equals 1.2, but I don't care about b to the 5th. I want just plain old b. So I'm going to take and raise both sides to the 1/5 power. So when I do that, this is what I get. So I'm going to raise this to the 1/5 and raise this to the 1/5. So I have b equals 1.03714, which is roughly 1.037. And I'm glad it's growing because this is growing. So I know the b had to be over 1. Oops, sorry. So now what I want to do is I know y equals a. I still don't know the initial value, but I know my growth factor is this. And what do? Well, we plug in one of the points. Well, we're going to plug in the point 20,000 because that's an easy point to plug in. So I have 1,000 equals a 1.037 to the 20th. So you see how this is hooked by multiplication? So I'm going to take the 1,000 divided by 1.037 raised to the 20th. And when I do, I get a comes out to be 483.532. So we're just going to do 483.5. If you were doing this for a test or a quiz, I wouldn't mark it wrong if you put it all there, but I'm going to round this roughly to 483.5. So my equation is 483.5, 1.037 to the x. And I don't want you to worry about rounding because I will tell you how to round, but definitely your exponential, your b, your growth factor should be at least 4 decimal places. Okay, now let's do it with graphs. Now both of these are exponential, even though I told you they curve so you can tell. This one I have the initial value because they told me the y-intercept. So here I have my initial value. This one I do not over here. They just gave me 2 points. So this one's always the easiest one. So I'm writing y equals ab to the x. And let's stack and rack the points. So I have the point 0, 15, and I have the point 3, 120. Now again, this is cool because I have the initial value, so I can put the 15 right in for a. So I have y equals 15b to the x. Now we're going to plug in this other point because this one's the easier one. I just plug in the other point now. I have 120 equals 15b cubed. So if we divide by 15 on both sides, I have 120 over 15 equals b cubed. Raise each side to the reciprocal, happens to be 1/3. So my b comes out to be 2. This one's a nice one. That was nice on this one. So my formula here is 15 2 to the x. Can you have that? Yes, you can, because that means it's been doubled. So it's really 2.0000, but there's your formula. Nice. And you can check it by plugging it in. Now this one over here, I have 2 points again. So this one I don't have the initial value. So this one I have to do the divide thing. I'm going to take the higher value first. So I do y equals ab to the x. 10.8 equals ab cubed. Divide, put the other point in. 138.89 equals ab to the -2. Thanks for playing. Hopefully this is getting easier. Now when I have the same base and I'm dividing, I have to subtract. So I have b to the 5th equals this ugly fraction, but that's okay. Not everybody can be beautiful. And I don't really care about the 5th, so I'm going to raise it to the reciprocal of 1/5 because I got to solve for b. I have to do both sides. When I put that in my calculator, I get b to come out to be about 0.6000. It's really nice. It comes out nice and even. So it's really nice on these. So now my formula is a 0.6 to the x. Now, all you got to do now is plug in another point, and what I used for the other point to make it easy is I like this number better. So I've got 10.8 equals a 0.6 cubed. So now, if I want to figure out a, these are hooked by multiplication. I just got to divide that on both sides. So a is going to be 10.8 divided by 0.6 cubed. And when I do that, a comes out to be 50. Wow, this did come out nice. So my formula is y equals a 50, and it's 0.6 to the x. Now, before I leave this page, I want to show you something. This formula is started at 15, and it's over 1, so it's growing, so it's increasing this way. Okay, that makes sense. This one started at 50, but that's here. It really was over here, but this crossed at 50, and it's 0.6. And do you see how it's decaying? My points are getting smaller and smaller, so that works. That shows you that the formula is telling you exactly what's going on. All right, the next example we'll do in class together, so that will be it for this tape.